Hi friends, today we are going to see how we can find skewness using Python. Without any delay, we will jump into our session now. We will understand what is skewness. So, see, I have a element which is this one. Blue is my element, and this uh, this contains 3 points: 1, 2, 3. So with that 3 I am just with the 3 point I am drawing a circle. Within that circle I am drawing an equilateral triangle. I am finding out the area of the equilateral triangle and my actual triangle. If I put the value in this equation, what I get is the skewness. Whatever I explained is for fluent. Okay, so this is the explanation which you need to understand about skewness. So for each element, our answer calculates these things and reports us. So today we are manually going to create a script which does the same thing like uh, answers element information does. Okay, so I have a V8 engine model. It's downloaded from GraphCAD. Okay, but I don't need all these parts. Okay, first we will open our script editor and go to file, new, empty script, and then go tools, code snippets, tutorial, header and input. So first I am defining my scope. Scope is find skewness. First we need to generate mesh and then we will come back here again. So go to your answer model and then toggle on this. I just need a simple part. I don't need this whole model. I just have only this PID and I want to make a mesh over this model. So go to the mesh and then spot mesh visible. Simply I have given spot mesh and visible. I haven't changed anything. Now if you go to click F11, it will launch you to the quality criteria. I am setting my quality criteria to fluent and 0.6. If you move your cursor over the fluent wording, you can find out what is the equation that is indirectly what is in background it is running. Okay, so we have 594 of elements, so that you can see these are the elements which are failing. So skewness failing elements is in green, so that is why here see this element is failing in skewness. How we treat it manually? So go to grids and then move surface. This option just moves this allows the node to move over the surface, and when the tria is almost equivalent to the equivalent to this isolateral tria area, equilateral tria area, which is going to be inscribed, then it will turn to be turn away from the off elements. So now I am making it as off. was the earlier question. We will go back to our slide. Okay, so to find out area of the triangle, we have Heron's formula. So in this, A is the length of equilateral triangles, and that A can be get from the radius multiplied by the square root of 3. You can see this derivations if you wish, otherwise just take the results what you need, and we need to use these equations in order to find out the skewness. So first, back to here. Okay, I am just concentrating only on this element, particular element. Okay, so I need to know the ID elements info. Go and pick the element. You can see its skewness is 0.65133, and the element ID is 233 and 52. So that first I am getting the entity. First define the deck, and then the type of the ANSA entity which was searching, and then its ID 233, and I am saving this as shell underscore 1. So for this shell I need to calculate the area. We can make use of measurement to calculate this one. Go to here, make measurement. See here, create measurement, and in this we need to pass the shell, and then we need to pass what we require here. So shell is nothing but the shell underscore 1. So for this shell I need the area from it. So that is the thing. So we can call it as measurement. So now it has created measurement, so that is also one type of entity. So from that entity I want to collect the results. So I am just creating, I want to get the values. Get entity card values. So I want to get the card values of this entity MSR1. So I just want to see. So this is deck, first one is deck, and then entity, this is my entity which I am interested, and then what I need is the field. That means what I need from this entity, this measurement is taking the area, so that area is stored into that MSR. So to access that we need to use the keyword result. So just passing that into a dictionary, list, and the keyword for accessing it is result. Okay, so this just gives the area of the shell. So I can say this is the actual area of our shell element. So we can print this now. Print actual area. If you now run this, see we have 1.12 sorry 1.261, that is the area of this particular element. So we will check this. So go to measure and then shells. Just I think the script which we run now here which we run has created a measurement. So that measurement has been stored in the ANSA GUI. See here the measurement has been stored, so that if you press Ctrl Shift you can clearly see all the measurements that has been made. So that measurement I want to hide. So go to, just press F12 and you can see the measurement is on of this one, and go to measure function now and measure the area. See the area is 1.261, the same one. We have finished our finding area, and next we need to find out the circumscribed circle. That we can easily get from the nodes of the shell. So first we need to collect the nodes from this shell. So that is base dot collect entities, and then we need to pass, first argument is deck, next one is container. I want to collect from the shell one, only from that element I want to collect the nodes. So keyword for collecting node is grid, and then we need to say true, recursive as true. Then you can check, because this shell contains only three nodes, because it is a triad. If you find the length as 3, then it's running perfect. Yes, it's perfect. So we have collected the nodes also. So from the nodes we need to find out the circumscribed circle. So for that, so see, if you go to measure here, if you go to nodes, select this node and this node and this node. If you select 3 nodes, you can see some options here. So you can find a inscribed circle, you can find a circumscribed circle. So in this circle there will be one equilateral triad. So I want to find out the area of the equilateral triad. So go to script edit, and then so I want to make use of the measurement function again. Just copy this one, MSR2 is equal to, but this time I want to measure the circumscribed circle from the nodes. So in nodes I want to calculate circle. Now in the same way I need to get this is actually when we make a measurement like circumscribed circle, it makes it gives the diameter, so I am saving it as diameter. Okay, so print diameter. So this is also a dictionary. Okay, this is a dictionary. Now we need to find out the area. So let's back to our slide. So we have diameter in our hand. So 3.33 is the diameter of the circumscribed circle. So from that we can find out the radius. So radius is equal to, so this is actually in a dictionary, so I want to use it. So diameter is the dictionary, so from the dictionary I'm calling result. Okay, so just copy this, paste over here. So this returns our radius, diameter divided by 2. Just print radius, sorry, yes, it's working good. So we have radius in our hand. Now if we go to our slide, so formula for finding one side A is square root of 3 into the radius. So we have radius of this one, so if we want to find out that A equal to square root, we need to run. So square root of 3, if you want to do such mathematical operations, we want to import max, and from math I want to import all modules, import star. Okay, now I can simply make use of the square root function. So square root of, sorry, yes, square root of 3 multiplied by this radius. See, so this is what here also. So after that, the area of the isolated tria, sorry, not isolated tria, equilateral tria, equilateral tria, equilateral area is, here we have the equation. So 3 8 to the power of 4 divided by 16, otherwise root of 3 a squared by 4. So that way I am going to utilize here, so that I am typing a square, okay, multiplied by its square root of 3, yes, divided by 4. Is it right? Yes, good. Print equilateral area. Yes, it's also working. So now it's time to find skewness. Skewness is nothing but this area minus this actual area divided by this equilateral area. So print skewness. Unsupported operand type. Okay, actual area is a dictionary. From that dictionary we need to access the result alone. So this is actual dict, we will name it as. So from that actual area is equal to actual dict of this result. The keyword is this one, accessing it by that keyword. Now it works good. See, this is our skewness. So print the skew, sorry, just paste here. Now run 651, we will check here. Now go to the elements info and check 651. So it is working good, our script is working good. So it is finding now only for one particular shell. If we want to do it for all, we can do so, because here we just collected only one entity. Instead of it, if I collect all the entities like shells is equal to collect entities of deck, and I don't want to prefer any container, I want to collect shell, and I don't want to use that, so I will collect all the shells. So this will contain total this 75,000. so for each 75,000 it is having 3 nodes, so for each cell it will calculate skewness. So go to the script. So for each shell it has to do for shell underscore 1 in shell list. Why I am putting shell 1 is because earlier I have defined everything by that name, so it will be easy for me if I use the same name. So now I need to make the indentation perfect, so I am just aligning to the right. So if I now run, it will run for everything, so I don't want to print these things again and again. Shift comment out these and this also. So if you type, so the skewness is skewness, and also we want to print the ID of the element, particular element. Actually we don't need all these things, I think. Shell 1 dot underscore ID this itself will run shell underscore one underscore dot score id. We will do one more thing. If skewness more than 0.6, then I want to add base dot I want to add this to a list. So I want to define a list and within that list I will add this. So list dot append that how many IDs, so how many shell are failing, that will be added. In the last we will print length of this list. This is nothing but the total number of off elements this one will give. So we will check out. So we have 9 off elements. So if that list gives 9 as the result, then our script is perfect. Just run. I think this should not run like this. If skewness is okay, list dot append since it is running for each shell. So here it has to be list. Yes, list needs to be defined here, and we can add, we can delete. So then we can print length of list. So since it's taking more time, I want to filter out, so I'm just taking only this PID, sorry, this entity. So it just contains 760 and 4 off elements. Just log this, and I want to check my script whether it is taking all the, it has to take only visible entities. So that's why I am giving here true. Now I am running. See, the length of the list is 4. That means our script is working very good. Thanks for watching. Have a great day.